Before we skip into the assertion, it is compelling to sort out what molecule gas petals are the monstrous Hadron Collider. LHC, work by CERN, is a 17M ring of superconducting magnets in like manner. It is the world's most noteworthy and most momentous particle smasher. It represents the pinnacle of human scientific accomplishment as an issue of fact. It's so solid that it would be able to reproduce the genuine states of the first involvement on the planet. Yet could this machine intended to open the mystery of the universe hold the way to something clearly something else? For CERN, spread out in 1954, is one of the world's most popular research associations with 23 member states and endless researchers. It's a place for coordinated effort and advancement. The LHC is CERN's central undertaking, but it's only one fragment of a gigantic organization of gas petals and tests. Imagine a course, not such a great amount for vehicles or people, but for subatomic particles in a preliminary of skill, diligence, and space itself. The LHC speeds up protons to, for all intents and purposes, the speed of light, sending them on a mishap course that reflects the energy of the universe. Right now, of the Big Bang, the impacts make temperatures commonly really burning than the focal point of the sun. A huge number of magnets guide the protons on their excursion, while complex cooling frameworks keep the magnets at temperatures colder than space. The pillars inside the LHC are made to crash at 4 districts around the gas petal ring, connecting with the spots of 4 molecule identifiers map CMS, Alice, and LHCb. Each fills an unprecedented purpose, investigating exceptional bits of molecule material science. Together they go about as beast cameras, catching depictions of these accidents. Specialists then channel through the trash looking for indications of the slippery Higgs boson, also called the God molecule, and different abnormalities that offer pieces of the universe's chief structure blocks. By zeroing in on the microcosm, we gain bits of knowledge into the universe. Yet with each answer comes another inquiry. With each disclosure, another test emerges. The LHC isn't just a logical instrument, it's an exhibit of human interest and progression. It epitomizes our enterprising mission for information and our yearning to get a handle on the key powers that shape our universe. Anyway, as we stretch the boundaries of what we realize, we should likewise think about the more upstanding and existential inquiries that emerge. What are the dangers of looking at the obscure? Could our main goal for seeing unexpectedly open powers we have zero control over in the holy halls of CERN, where the limitations of human comprehension are ceaselessly pushed? A disclosure has arisen that sends a shudder down the spine of even the most prearranged researchers. Brian Cox, a previous scientist at CERN and a voice of expertise in the domain of molecule physical science, has as of late said something that has left the world both enthralled and uncomfortable. Cox's words reverberate with chilling lucidity. The goal of CERN's huge Hadron Collider is to copy a small-scale Big Bang. Yes, you heard that right, a little rendition of the very occasion that brought forth our universe. The physicists likewise ended up making sense of the implications of this goal, featuring the LHC's amazing potential for making new discoveries. This includes its capacity to open the privileged secrets of the Higgs boson and investigate dark matter, a strange substance that makes up a critical part of the universe. Imagine holding the force of creation in your grasp. The capacity to invoke the actual embodiment of the universe is an enticing chance, but one stacked with risk. The scaled down Big Bang isn't just a theoretical idea, it's a substantial reality inside the LHC. The temperatures, the tensions, the crude energy all duplicate the states of the universe's introduction to the world. It's like standing at the beginning of written history, seeing the introduction of presence itself anyway. With such power comes obligation, and the inquiry looms. Imagine a scenario in which something turns out badly. In fact, something did go wrong back in 1978. The Russian physicist Anat Borsky encountered a disaster that would forever adjust the direction of his life. While chipping away at the U-70 synchrotron at the Institute for High Energy Physics in Poo, Russia, fizzle made his head coincidentally come into the direct way of a proton beam. The beam, with a force that opposes cognizance, went through his skull, entering the rear of his head and leaving through his nose. Borsky's experience was outrageous. He saw a blaze brighter than 1,000 suns, yet had no stresses. The beam's way left a path of destruction, consuming tissue and bone, but he stayed cognizant and even walked to the center for treatment. The result was both upsetting and captivating. The beam's way caused limited tissue harm, leading to hearing loss in one ear and partial facial paralysis, yet astonishingly Borsky's intellectual resources stayed intact, and he continued his scientific career. This episode isn't just a personal misfortune, it serves as a reminder of the monstrous power and potential risks of molecule gas pedals. The dangers of a particle smasher like the LHC are not to be underrated. The potential for alarming reactions, the very fabric of existence being changed. These are not the stuff of sci-fi, but genuine concerns voiced by some regarded specialists. One of the most upsetting and captivating concerns connected with the LHC's test is the chance of making a little black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are huge vacuum cleaners, devourers of stars, strange substances that hide in the shadows of our universe. The fact that the LHC could make such a substance, even on a brief scale, is staggering to both the public and researchers alike. Could this black hole eventually grow wildly, gulping the Earth from the inside? Researchers in turn have guaranteed the public that any black hole made would be unsteady and vanish very rapidly anyway. The distant chance has ignited conversations, fears, and a sense of wonderment at the power we wield. It's essential to understand how the LHC could make a black hole. It has to do with the key mechanics of molecule gas pedals. When protons are crushed together at almost the speed of light, the energy made is so gigantic that it twists the texture of space-time itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The texture twists, and if the object is heavy enough, it could make a depression so profound that anything nearby would be drawn into it. This is a simplified analogy for what could happen at the LHC in the realm of quantum physics, where the laws of the universe are both odd and wondrous. There exists a hypothesis that additional dimensions might be hidden inside our existence. If these dimensions exist, the LHC's investigations could take advantage of them, making a gravitational well that forms a little black hole. This strange dance of particles has even grabbed the attention of a few exceptionally famous scientists, particularly the late Stephen Hawking. In his book, he warned of a situation where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a destructive vacuum decay, a devastating event that wouldn't just obliterate the Earth, but might actually obliterate the entire universe. The regarded English cosmologist and astrophysicist Sir Martin also expressed concerns about the experiments conducted at CERN. In his book on the future possibilities for humanity, he explored the potential dangers of particle collider tests, including those at CERN. His words were not just prudent, they were pervaded with a sense of existential trepidation. He discussed a worst-case scenario where a failed experiment could create a condition called vacuum instability. This instability could in theory trigger a phase change that would reverberate through the fabric of space-time, resulting in a catastrophic event that could engulf the entire universe. Concerns were not limited to theoretical speculations. He assigned a low likelihood to these catastrophic results. However, he argued that even a small chance warrants serious thought. The stakes are undoubtedly high and the margin for error is razor thin. The specialists at CERN have run simulations, analyzed the theories, and taken every precaution to ensure the safety of the LHC. In fact, Brian Cox himself recognized the importance of this, acknowledging the widespread concerns surrounding the activities at the LHC. He emphasized that there are thorough safety measures in place, thorough reviews and protocols to ensure that the LHC's operations are carried out with the highest possible level of attention to detail. Cox reassured that the energies involved are, well, within what the Earth naturally experiences, and the possibilities of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so small and unstable that it would dissipate quickly in an eruption of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief moment of massive wonder, a fleeting glimpse into the void, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many and has become a topic of interest, fear, and even legend. What lies beyond our universe? Could we accidentally unleash forces or entities that we don't understand? The idea of opening a doorway to hell has even been sensationalized in various media, fanning the flames of uncertainty. But how did this idea emerge, and what does it mean in terms of scientific investigation? The concept of extra dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the standard 3 dimensions of space in one of time. These extra dimensions could be compactified or hidden from our perception, but they could hypothetically be accessed or revealed under extreme circumstances. Now, imagine the LHC as a cosmic key opening doors that have been locked since the dawn of written history, when protons crash at energies never before achieved. On Earth, they could in principle create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC might actually uncover them. But before we indulge in wild speculation, it's important to understand that while the LHC is undoubtedly powerful, there is no conclusive proof to suggest it will open a portal to another universe, let alone to hell itself. Nonetheless, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of global catastrophe, but the truth is the scientists at CERN are highly aware of the risks involved. They have taken every precaution to ensure that their experiments are safe, and they continue to monitor and evaluate their work with the utmost diligence. The potential benefits of the research, the advances in our understanding of the universe, the discovery of new particles, the study of dark matter are truly extraordinary. It's not just a showcase of human ingenuity, but a window into the very heart of the universe. Anyway, like any great leap forward in science, it comes with its share of dangers, and we should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark Matter is unparalleled anyway despite thorough safety measures and meticulous calculations. The LHC still evokes a sense of mystery and fear among some. The sheer size of the machine and the energy it produces are staggering, and each new experiment opens the door to strange scientific realms. While most researchers remain confident about the safety of LHC experiments, there are obvious vulnerabilities. What if new surprising anomalies arise that challenge our understanding of physics and the laws of the universe? The LHC stretches the boundaries of human knowledge and tests the limits of our control over the natural world as particle collisions recreate conditions hidden since the Big Bang. The significance of these tests raises existential questions about the potential outcomes of altering the very fabric of the universe. Nonetheless, the LHC's achievements in particle physics have been substantial. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and open pathways to potential breakthroughs that may one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without danger, and the LHC is no exception. Its tests dive into realms of physics where intuition no longer applies. For decades, physicists have tried to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a critical role in the development of matter.